All right, class, today we're going to talk about equivalent fractions, or equal fractions, okay? And so the first thing I want to talk about is, what is equal about them? So look at these two fractions, 1/2 and 1/4, okay? Both of these numbers have one part, or one piece, right? They're both ones. 1/2 and 1/4. So are they equal? One half and 1/4, are they equal? They both have just one piece. 1 equals 1.
No, because 4 is bigger than 2.
Okay, so 4 is bigger than 2, which means that this one is cut into how many pieces? 4 pieces, and this one is only cut into 2 pieces. So when we're talking about equal fractions, what are we actually talking about? What are you trying to find, or what are you getting with equal fractions? What is equal about them?
They're the same amount.
They're the same amount, equal amounts, okay? It's not the numbers that are equal, it's the amounts that are equal. So 1/2 is equal to 2/4. Okay? We're talking about an equal amount of something. As long as the pieces are the same size, which we talked about last time in understanding fractions. Okay? So, to find equal fractions, what we will be doing is multiplying or dividing the top and the bottom numbers by the same number. It's like cutting one so that it's equal to the other, or multiplying one part so that it is the same amount as the other one. Okay? Let me show you how this works, what I mean by this. Let's say that we're starting with a fraction like this. 3/5. 3/5. Okay? Now, if we have 3/5 of something, so that's a sketch of fifths, and if we have 3/5, if we were to cut this whole thing in half, we're multiplying this 3 by 2. Okay? So now we have how many parts? How many pieces? Hello? 3 times 2. Hillary?
6.
6. Now we have 6 pieces. We cut them all in half. And if we cut the pieces in half, we cut all the pieces in half. So we have to multiply the bottom number by 2. So instead of 3/5, we have 6/10. Okay? Now, it also works the other way around. If we're starting with 6/10 and we want to find an equivalent fraction, instead of cutting them all in half or multiplying them by 2, we are putting the pieces together. Oh, let's do it this way. So if I just go backwards, going way backwards. There we go, 3/5. So we had 6/10. This is 6/10. And if we get rid of this line, oh, I should have written 6/10 first. Then, I'll just do this. Getting rid of this line. Now we have 3/5. So we divided it by 2. If you divide them both by the same number, you're putting them together. Okay? Does that make sense?
Yeah.
Because 6/10 divided by 2 is 3/5. So they're equal amounts.
Oh, I don't know.
Okay?
Oh, I know.
Let's try some from your assignment. Look at page 113. Make sure, open up the books to page 113. So, starting with number 1, what equivalent fraction does that model represent? What equivalent fraction does the model represent? Raiden, what's the top row represent?
3/4.
Yeah, 3/4. There's a block and each one is 1/4. So this equals 3/4. And that's equal to what? On the bottom of that, it's equal to 9/12. Yep. Each of those is cut into 12ths. And then there are 9 of them. So those are equal amounts. Okay? Number 2. If we're starting with a fraction of 12/15ths, what common factor can we use to put pieces together? In other words, what can we divide these by to put them in groups? What can we divide both of these numbers by?
3.
3. So divide this by 3. Divide 12 by 3, what do we get? 12 divided by 3 is 4. And 15 divided by 3 is 5. Yep. And so what we are doing here is putting this number into what's called simplest form. Simplest form. What is simplest form? Let's go back to our notes. Simplest form, write this down, sometimes it's called lowest terms. And what that means is that there are no more common factors in both numbers. The numbers do not have any more common factors. And that the top number, the numerator, is not a factor of the bottom number, of the denominator. Okay? If the top number is a factor of the bottom number, then we still can divide it. Okay? So then they have a common factor. The top number is the common factor. So what we're looking for is if they have a common factor. All right? So, in other words, if one of them is a prime number, like 7, 7 is a prime number, isn't it? Are there any other factors of 7 other than 1 and 7? And since 4 is not a factor of those, then 4/7 is in lowest terms. Okay? But when you look at prime numbers, for example, in this one, 17/34. 17/34. Is 17 a prime number? Yes. So it wouldn't have any common factors to 34 except what? Ethne. Except itself, yeah, except 17 goes into 34. So then you can divide both numbers by 17. So you have to make sure the top number doesn't go into the bottom number if it's a prime number. Okay? You could also figure it out by thinking, well, 34 is not prime. What is 17 divisible by? Or sorry, what is 34 divisible by? Because it ends in an even number, it's divisible by what?
2.
2. And 2 goes into 34 how many times? Come on, people, it's right here. 17. 2 times 17 is 34. And so now we can see this common factor. So divide it by the common factor. Anytime you know there's a common factor, divide both numbers by that common factor. Okay? Whenever the top number and the bottom number, whenever the numerator and denominator have a common factor, then divide them by that common factor. Okay? So, let's see. For example, number 5. 6/8. What is their common factor? What's the common factor? What number goes into both 6 and 8? Megan? 2. So divide them by 2. What do you get? 3/4. Okay? How about this one? 33/55.
11.
What goes into 33 and 55?
Oh, I know.
Matt?
11.
11. So divide them both by 11. What do you get?
3 and 5.
3/5. Is that simplest form? Is that lowest terms?
Yeah.
Yeah. Okay, they're both prime numbers, and they are not factors of each other. Okay? Any questions? All right, what I want you to do is, starting on page 114, do numbers 9 through 39 odds. 9 to 39 odds.
Okay.
Now, it's sometimes you have to factor it more than once. For example, the first one, 70/75. 70/75. All right? What are they both? What factor goes into both? 5. So divide them both by 5. Okay? I guess that one actually already gets you to the lowest term. What if it was a big one, like 140 over 150? Okay? Oh, yeah, that's true. If you were to divide them by 5, then you would get 70/75. And then you can divide them by 5 again.
And keep on dividing by 5.
And keep dividing. In other words, what I'm trying to say is, sometimes you have to do this multiple times in order to get to the simplest form. Okay? So don't just divide them once and think, oh, that's simplest form. Make sure that you keep dividing if you can. Okay?
And it's
Yep, it's lunchtime.
Yeah.
You didn't want